What if we take the same shape and rotate it about the y-axis? How would that change how we found the volume? So if I take, here's all my little a sub i's that exist in the plane, and if I rotate one of them about, well, let me rotate the figure. I guess I haven't really constructed the rotated figure. So trying to make a nice little ellipse in the bottom. It's got this like nose cone, rocket nose cone shape or bullet shape. Put that back there dashed. So we have this, and we'll put the shading on this side. A little bit of shading. Can I do that? I don't know. Or am I just going to ruin it? Sometimes I try to like shade and make it look 3D, and I just ruin it. All right, well, that's not bad. I don't want to ruin it. All right, anyway, so there you go. Now, what happens to this representative rectangle? Well, once again, it's going to rotate, but this time we're rotating about the y-axis. So we get a disk going this way, and then that's the bottom of the disk, and here's the top of the disk. I just, I would flunk out of art school in a day. All right. But what I can do is pull that disk out and say, okay, what I'm really looking at there is a disk like this. Okay. And so what's my v sub I? So, really like a lot of calculus analysis comes down to look at how you would represent a series of ith intervals, and then look at that ith element and analyze that ith element and then integrate it. Right? You do, because you could be doing not necessarily volumes. You could be doing something like total energy or charge contained within an area, something like that. All right, so VI is still pi r squared h, because this is a cylinder, which is, when it's flat, we call it a disk. The height now is what? What's the height of the cylinder? It's delta y this time. All right, now the radius of the cylinder is what we have from here to here, right? From here to here. Let's see if I can do that in a contrasty color. So here's our radius right there, and it's the x coordinate, right? So the x coordinate is going to depend on y. So that means, this is already our hint that we're going to integrate with respect to y. So that means that we need to solve this equation for x. So I would have x squared equals 4 minus y. And then I would have x equals plus or minus the square root of 4 minus y. So the positive would be this side of the parabola, and the negative is this side of the parabola. It sort of looks like we're using both, but we're really not, because the region that we're rotating is in the first quadrant. Remember, it was bounded by the x-axis, the y-axis, and the curve. So we're really only going to use the positive part of the square root. So we've solved for y, and that's what our radius is going to be. It's the x coordinate now. All right. So now when we do the volume, is going to be the integral from a to b of, well, I guess we have to sort of finish this up here. So our volume sub I is equal to pi. So our r squared is going to be f. So what we'll call this is f of y. I mean, I could call it something different like g, but I thought that would get confusing. So f of y squared, and our h is the delta y. So it's going to follow that our integral is going to be the integral from a to b of f of y dy. A crucial difference is that now the limits are y coordinates, not x coordinates. All right, so that means that our a is here at 0, a equals 0, and our b is up here at 4. B is 4. All right. And what kind of things did I forget? I forgot all kinds of things in here. I forgot the pi. I forgot the square, the f of y. I forgot everything. All right. But so, because all of these elements here should occur here, and now they do. All right. So that means, maybe I should rewrite that. V equals pi times the integral from a to b of f of y squared dy. It doesn't really look much better, does it? Anyway, so that is pi times the integral from 0 to 4 now, because these are y coordinates. Now my f of y is my square root of 4 minus y, right? Square root of 4 minus y. But see, then I'm going to square it, so isn't that nice? So I have square root of 4 minus y squared dy. And then that's nice and easy. Oh, yeah, I just realized I forgot to show you the answer to the other integral. So v equals pi times the integral from 0 to 4 of 4 minus y dy, because the squared and square root cancel out. So that's an easy one to do. I'll let you finish that one up. while I figure out why there's a big shadow on my screen. There we go. All right. So I'll let you finish this one up. Meanwhile, let's go back and look at the one that I forgot that I hadn't finished. So here's the integral that we had set up for this guy. The integral we had set up for this guy. So I guess you can't really do a u sub on this one because you don't have an x out here. So I just squared it out and, you know, blah, blah, blah. The only thing that I was going to, I got 256 pi over 15. And then I checked that with a calculator to be sure it's right, because it is. So one of the things that I did when I was doing this without a calculator, so I started without a calculator, is to say, you know, when I was looking at this with the 32, the 64, and the 32, I said, look at all the common factors of 32. So one thing you could do is factor out a common factor of 32, and that would simplify the work. But the other way that you could do it that I often choose to work is let's just put everything in terms of 32. So when I'm doing my common denominator here, we've got to go 5 times 64, boom, 3 times 32, boom, right? And then my denominator is 15. So what I did is I said, let's leave everything in terms of 32. So for example, 5 times 64 is 10 times 32 because 64 is twice 32. And then when I get a common denominator for this one, I'm going to have 32 times 15. And what I'll do is just leave that as 15 times 32. So the reason I'm doing that is then I have these 32s. So I have 15 32s minus 10 32s plus 3 32s. And so what I'm going to do is just say, okay, 15 minus 10 plus 3 is 8. So I have 8 times 32. And then 8 times 32, those are powers of 2. So if you know your powers of 2, just say what power of 2 ends in 6, right? Because it's going to be 8 times 2 is 16. So what power of 2 ends in 6? 256. So 256 pi over 15. These are some mental math tricks that I like to use. Notice it's really helpful to know your powers of 2. I didn't know this was coming. It's just something that comes up a lot. Know your powers of 2. 1, 2, 4, 8, 16, 32, 64, 128, 256. Right, 5, 12, 10, 24, 20, 48, 40, 96. Know your powers of 2. They're very useful mathematically and for computer science. Okay, so this is the integral we get for this one. You work this integral out. I will this time not forget to write it out, and then we'll try to summarize what we've got so far and do some more problems.